Hello everyone, I hope you are doing great. In this video, I'm going to share with you some important insights about the basics of latent growth curve modeling, and then in the subsequent videos, I will show you how latent growth curve modeling can be implemented in EQS. So, latent growth curve modeling is used to study change patterns in variables over time, and this change could be either a linear change or a curvilinear change. With respect to sample size, you need to have at least 200 subjects at each assessment point. And if the change pattern that is being studied is assumed to be a linear change, then data should be collected at 3 time points. However, if the change that is being studied is assumed to be a curvilinear change, then data should be collected at 4, 5, or 6 assessment points, depending on the requirements of the analysis. And with respect to the time gap between each assessment point, it should be noted that time points can be evenly or unevenly spaced. And finally, with respect to the implementation of this type of analysis, LGC can be done using SEM framework or structural equation modeling framework, and also in the context of multi-level modeling. Now I'm going to show you a few examples of LGC modeling in the context of structural equation modeling. So this is the first example, and in fact the most basic type of LGC model. And here in this example, we are focusing on 400 students, and we would like to study the change pattern in math ability of these 400 students from year 1 to year 3. So you can see that data have been collected at 3 time points. In this figure, which is considered as a unidimensional LGC model because you are just focusing on math ability of the students, there are 2 factors. This factor captures the mean of math ability at the starting point of our assessment, which is year 1, and this factor captures the change rate of math ability over a course of 3 years. So these 2 factors are very important, as well as the relationship between these 2. Because by studying this relationship, we can study whether there is a relationship between the mean value of math ability of the students at the starting point of the assessment and the change rate of math ability of the students over a course of 3 years. So these are the 3 research questions that can be answered using this simple model. Now let's make it a little more complex. Okay, in this slide, you can see a multi-dimensional LGC model. It is multi-dimensional because we are focusing on math ability and science ability of the students. And we can have the same 3 research questions for science ability as well. So the mean of science ability, change rate in science ability, and the relationship between the mean and the change rate in science ability are the 3 extra research questions in this model. We also have 4 research questions corresponding to these green double-headed arrows. For example, if you are interested in studying the relationship between change rate in math ability of the students with the change rate in science ability of the students over a course of 3 years, you can focus on this double-headed arrow and answer this research question. So overall, 10 research questions can be answered using this model. Now let's this model a little bit more complex. Here we have added gender as a time invariant covariate to the model, and therefore this model is capable of answering 14 research questions. For example, if you would like to study the difference between male and female students in terms of the change rate in their math ability over a course of 3 years, you can focus on this arrow. Finally, we have added personality of the students as a time-varying predictor to our model, and therefore, this model can be used to answer 20 research questions. So the extra 6 questions are represented by these arrows. For example, if you are interested to assess the impact of the personality of the students in year 1 on their math ability or on their science ability, you can focus on these 2 arrows. Okay, it was all that I wanted to share with you with respect to latent growth curve modeling, and I hope you enjoyed this very quick presentation. Thank you and goodbye.